Hello and welcome. I decided to deviate a little from my series of tutorials about making Sakura tree and instead make, hopefully short, one tutorial about railings made of procedural twisted vines. So hopefully you like it. Let's jump in Houdini, and here the base what I need is my stairs curve. I'm not gonna stop at the process which take to create this curve to count the amount of points for the stairs and everything. If somebody is interested, let me know. I'll explain that too. But let's say that we do know the shape of our stairs, and we have the curve, and also we have a base, the tree, which again it was created. You can see that stairs are already cut out of it, but again it's a question for another tutorial, because it's not the fact that somebody else will have a similar situation. The point of this tutorial is making twisted vines. So let's just accept the fact that we have a curve for stairs with points for each step. And so let's see how to create railings in this case. And we'll start from the steps first, because we need them to calculate the positions of railings. So let's say that we create a box for our stairs. Box is 1.5 meter long, 3 centimeters tall, and 55 centimeters wide. And also for center of it, I copy parameter of the height, size y, pasted it as a paste relative reference here, and divided it by 2. So I would have it not in the middle, but like laying on the 0 point. And also did the same with z. So I have it not in the beginning of coordinates, but in the middle in z direction. I'm sorry, not in the middle, but actually moved into this direction. So we have the center back side of the stairs is our middle of the world. What I did next is I split polygons by normals in x direction, and that's how I got my two short sides. And I added them to the group named sides, group of primitives. Then I transferred this group with the group transfer node from this newly created group onto the step itself. Group transfer with settings, and I selected the group that I want to transfer, and that's how I got my step with only selected sides. And then I do split. So now I have in one hand my sides, in one exit of the split, which I split it, you can see by the group. Then I sort them by x, and so now I have primitive, my primitives, hold on, yeah, not the points, primitives. So I have my primitive 0 and primitive 1. And then I split them again. So the left, while I sorted them by x, I know that the left one is the first one, so it's 0, and the right one will be the 1. So I split them just by the number, because I know that 0 is this one. And I use the node extract centroid, primitive and bounding box center, and that's how I get the very middle of my side. And I add it to the point group and call it left. And also I do the same with the right side of the step, extract centroid, and add it to the group right. And now I also took the step itself and added to the group step, primitive group step. And then I merge everything together. And as you can see, now we have our step and 2 points on each side, on each short side. That will be the points to create our railings. Now, while we're gonna copy this step onto our curve, I need to pack this. So the whole thing, the setup of several points and polygons will be all treated together. So I just pack them and transfer attribute name and pivot location is origin, so pivot location is 0. And this is my just null, just for easiness of working with the nodes. So it's stone step. So in reality, this is like a low poly step, like in actual project. And then there was also another actually high poly step, a stone shape. So it even made more sense to pack everything. But again, I simplified the whole thing for the tutorial only to just make it quicker. But yes, it was also high poly carved stone step added to it. There are actually several types of them too. But again, this is all a question for not this tutorial. So now we have our curve and we have our step. Let's say we just have one variety. And then we just copy 2 points and we have all the steps copied. Nothing interesting here. And after we're done with this, we unpack it. And now we have all of our groups separated. And while you remember that we did group left and group right, from here we can do blast and blast everything else. Delete not selected, everything else except group left, and we have all our points of each step left side. And also we have the same for the right. But while the process is exactly the same, let's just focus on one of the sides. So now we have our sides of our steps. We'll add them all together. So this is our left steps. We're adding them all together with add node by polygon and just all points. And this is our another null just for clarity of the whole setup. And it's called left railing. And if we look into our stairs here, you'll see that it exactly matches the shape of the staircase. What I do now is I move it a little bit to the left, literally just 10 centimeters. It's only to avoid, like if you look into here, no, it doesn't work like this. Let's do this. Okay, so I'll just try to explain. So this part of the stairs is got of the tree trunk is kind of a little bit it's roundish, and I just wanted to move the curve a little bit from the edge of the stairs. That's why it's just a slight movement. It doesn't have to be like this. But anyways, we have our first initial railing, which follows the curve of the tree too. Now what we need to do, we need to decide how many railings, like here. So you can see that each one of them is the vine, and they are actually situated in the same distance from each other. So we need to decide how many of those we want. And I looked and got to conclusion that in my case 40 for the left side, 40 was the best number, and then I'll show you how the other numbers look. For the right one, I'm using 30. So we're just copying them, and you can see that there are many lines right now. And what we need to do now is to work with each one of them and process it. So we create for each loop. Let's start it like this. So for each begin, for each end, standard procedure, and also we need to be able to access each one of them separately. And to do that, we create the metadata node, which is done like this. You select your block begin, create import node, click create meta import node, and name it to whatever, left, and that'll be good enough. So whatever you name it, that's what you're going to be using. So up to taste. So what I'm doing next, let's take just one of them, for instance, first one. What I do next, now I want them, each one of them, to be unique. That's how we're gonna create this chaotic look. So instead of using the whole length of the railing as we have in the beginning, I want to carve it. So make it shorter, and make it shorter just by random number, depending on just random chance. And you know that we can have we can have in this metadata node, we have iteration. We can access each iteration separately by its number and use it as a randomizer. So let's look into this curve. It looks pretty difficult, but don't be afraid. So we have our copy, our 40 nodes. What we do in a curve, let's create a new one just to restore the way of my thinking. Let's see. So first, what we do? Let's look into each railing here. So let's access the number of iteration. How we do that? We just go, for instance, we go here and we do detail. Use the syntax, and we named our node left. So let's look for the left. We have it. Now we look into iteration parameter and the first one, so number 0. So, and we see 1. Why 1? Okay. So if we go into the first if we just do single pass, we'll see that the first one will be 0. For the second one, the second pass will be 1, and that's kind of it, because we ran out of numbers. So we need to randomize it more. And what we need to do is we can access actually the amount of the copies that we have. So what we do here is we can go to total number, copy parameter, or just don't have to select it, just copy parameter, and then here we paste relative reference. We just need to have this curve works from 0 to 1, and we just need to make this number smaller than 1. So here we have number of our lines, and if we divide 1 by this, I said, okay. Let's see what's going to happen if we do this. Just this. Then for our first pass, we'll have 0.025. For the second one, we'll have, hold on. Oh, okay. So now we have, this is the static number because we just divided 1 by 40 in this case. And now what we can do is actually multiplied by our detail, and then we'll have something more interesting. We'll have this, and then for the other one we'll have something different. We can just make them how to show it better. Like you can see that each last of them, each following of them becomes shorter and shorter, and we need that because in the very end of the railings there is not much room to go because our railing ends here. And yeah, it's for randomizer we would use a randomizer, but now here the goal is to make the vine shorter, at least shorter in the top part, because now we just work with this. So it has to like come out of the stair and pretty much end right here. So that's why the further we go in our numbers, the bigger the number gets, the closer we get to the 1. And that's how we achieve this result. Okay, so now we have our, let's go to some bigger pass, so we'll have longer line. So now we have our line, and each one of them is shorter than, each next one is shorter than the previous one. Now let's do, just make it twisted, and the easiest way to do that is to just place a spiral along it. So we use spiral node, which is just create simple spiral. You can see my settings. Height, for some reason, 4 meters, 18 centimeters, can be more, can be less. It's all, it's just all a case of what you need in your exact situation. But what I do here is I do I want to make a random amount of turns for each pass. And you can see that this is the best way to randomize it. And here we actually do randomize it in a correct way. So let's train. Let's restore this this math so it will be a little bit easier to get. So what we do is we take detail of our metadata, and we randomize it, and then we feed it. So how I usually do that is like, okay, so we have spiral, and we need to create random number of turns within limits. So let's first get into our detail, and we're looking into our left metadata. Just so once again, actually, I can just go and copy it from here. So okay, so first we do this, and now we have amount of turns depending on what I have here. This is not what we want, but at least it's already different each turn. So we take this, and now let's use a random node to have random value each time. The problem with this is that random returns a value from 0 to 1. So yes, we do have different value each time now, but it's never 1. What we now need to do is to fit whatever we have from 0 to 1 to the limits that we want. In my case, as you could see, it was 4 to 11. And to do that, we need to put whatever we have here into fit01 node. So I start type fit01. I open the round brackets, and then I don't forget to close it again. And here first we have our value. It's already in. Now we do comma, value to replace 0 with, and value to place 1 with. And this is our randomizer. And now you can see that it's every time it will give different amount of turns. But it will be always from 4 to 11. This was the best in my case. And you can see there are there is no increase per turn, so the spiral doesn't grow in diameter. It just goes, because of the height, it just goes up. And that's it. And then we use path deform to deform our spiral along the line. And that's pretty much it. And while again, I can use fraction of curve lengths to make it longer, to make it occupy the whole spline, but I didn't, which again makes me questioning why I was to bother with curve. But well, I guess that was the initial idea, and I have no idea actually why it didn't work that way. Probably just changed my mind somewhere in the way, but I never changed the curve node. So anyways, so in the end of the day, with this in the end of the day, with this selected, we have all our spirals instead of each spline. Okay, let's get back. So next is transform node, and what we do here. What we do here is actually we move the railing up, because railing, so far we were working with the level where the step ends, and we need to move railing up, so it will occupy again some distance. It will be somewhere in between the actual step and the height that we willing to get. Usually it's like, I don't know, 90 centimeters, so 3 to 4 feet. So we just need to move each individual spiral on different distance, random distance, and you can see exactly the same syntaxes that I was using before. Again, we have our detail for each iteration. I'm not going to retype it again because it doesn't matter. So we have our detail. Then we randomize it with this, and I have extra brackets. Then we randomize it like we did before. So we got everything from 0 to 1. And now we want to turn it from 0.1 to 1.1. And that's how we do it. And that's why if we don't do this, then all our spirals will be just on the level of the steps. And with this, they all go into just randomly go somewhere. So okay, now we have our 40 spirals, all spiraling, looking good. Let's go see what's next. So now we're going into, now we're creating a group by range node. And what it does, it selects the very beginning of the spiral. So the first point of the spiral, which we will just drop down on a lower level and continue working with this. So as you can see here, we take this one point, end point, watch the normals, and we apply to it normal. It's just simple attribute wrangler or a wrangle. So we make this point to look down, normal of this point to look down. So this is the syntax. It's extremely simple. And after that, we're using the ray node to project this point down until it meets the geometry. So what do we use for geometry? Here we use our tree. Tree from here. As I said before, it was created the whole bunch all together. But so yeah, bear with me. So this is the tree, and now I do a little bit of poly extrude of it, 0.035, so 3.5 centimeters. I increased it to accommodate for the thickness of the future vines, because if the line will lay right straight on a tree, then the vine itself would be clipping through it. So I extruded just a little bit, and also I created a grid. It's just simple plane that works as the floor, and I merge them together to just have a whole picture. And so I'm projecting my first point looking down. I'm using a ray SOP. Let me uncheck this. And you can see that it's supposed to find actually the tree. Let's see. Let's look into one of the other ones. Okay, and you can see if I do this, that it's projected on the tree surface. So it was here, and now it's projected down. And so drop down because we use here project rays option. And we also make sure that we only work with the end group, only with one point in the very end. So this is how we are getting we're bringing all the vines ends down closer to the tree from wherever they are as of right now. And after this, you see now we have this ugly straight line, and we do resample to just make more points, or to smooth this line, and also actually make less points through the curve. And we also use subdivision curves setting to make it smoother. And that's it. So after this, in the end, we have all our spirals. Let me check this and check the tree. No, check the tree and do this. So you can see that now we have all our spirals with their ends touching the tree. Or if not tree, then touching the ground. So touching something. And after this, let's make them messy. And we go into point jitter and do this. So those are the settings that worked in my case. So I move each point except for the end point. So I'm only not touching this point that we dropped on the tree, the starting point. And you can see it here that everything is moving except for the first points. So let's say it will be 1. So except end, I'm moving them a little bit in X and Z direction, and I'm moving them a lot in Y direction. So now we have a mess. And let's get back here. And also, when we did resample, we lost our end group. So let's create it again. I mean, our end group was like diluted. If you look into here, it was one endpoint, and here it's 38 endpoints. So let's recreate this group again, and that's why we use replace existing standard merge mode. That's why they are not they're not being added to the previous group. They're just being created again. So we're doing exactly the same, just first points, and we blast everything except those first points. So now we have only the points where our railings are connected to the tree. Now what we do is, let's see. Well, first we add to them normals. Again, pointing strictly down. And also we add additional attribute to them. You can see ID attribute that is equal to point number. So you see that each point number gets the same ID attribute. We need this for the future. So just bear with me. So what we do now? Now we need to create these routes going everywhere from the stairs. And that's exactly what we're doing. To do that, let's say that we don't have, we're going to destroy all of our points. So we go into transform. What is this? Okay, we go into transform, and this was before, and this is now. Well, first we move them up, we move them to the left, we scale them, we rotate them. So we just, depending on the shape, on where these roots need to go, where your vines would go, you just need to just experiment and see where it takes you. But anyways, it needs to go somewhere like outside of it, like in my case. And also do point jitter to make them completely messy all around. Again, settings just the ones that worked specifically for me. And after that, we take our initial points, the ones that are resting on a tree. We take in our messy points, add them together, and now while we created ID attribute here, and these points inherited it, now we can connect each starting point with a corresponding end point using add node. And in add node, we use by attribute, and our attribute is ID. So that's our result. And again, point jitter can make it very, 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 very different result, can give you very different results. So just play with it. After this, so while we have just straight lines here, we need to resample. We need to have more geometry here. This is the settings, so pretty small. And after this, we again add normals to each of the pointing down. All of them looking down for future projection. Also, we manually delete group end. Actually, it shouldn't be necessary, but for some reason I did it. Yeah, it's not necessary. I actually don't know why I created this group. So anyways, we create a group range again. Again, I call it end. But this time we select 2 points, because if we just select 1 point, then because of the thickness of the tree here, we might lose the second point and get it going right through the tree. So it's better to select 2 or maybe 3 points, depending on the situation. Okay, so 2 points selected. Now we do point jitter for everything except our end again. So we make them messier, kind of like this. Somewhat like this, and then we smooth them a little bit. Again, except end, constraint points are end, so we don't want these points to move at all. And after that, we do projection, like we did before. So we project our points only on a tree, and you can see that they that they are situated. And in array SOP, we created, in this case, we created array hit group. So we only, so we add into the group the points that actually hit something, so hit the tree in our case. And the points that didn't find their goal, they then don't receive the group. Now we create another group SOP. We name it end. Yeah, I don't have any imagination, I guess. We do union with existing. Oh, right, that's why. Okay, I do have imagination. So we have group end here, these 2 points. And now we just add in to existing 2 points all the rest points from the array hit group. So we add into our initial points the points that found their geometry underneath. And after that, we blast in everything else. And we ended up with this, again, mess, but looks already like something that we need. And now, again, total lack of imagination. We create our group start to find the outside points, the furthest point from outside. And in this case, what we want, because you can see that they are not touching the ground, and we want our vines to come from the ground, like so. It would be nice if they would not be touching the tree, but procedural approach sometimes not exceptionally precise. So we create our start group. We create a grid that serves as a floor. Could actually reference the grid from up there. I just wanted more clarity. So like this, and then we project them down again. And actually, this grid, that's why I could not use the other one. It's located not at 0. It's located a little bit below 0 because we want them to dig into the ground a little bit in case, we have landscape change, shift, or something. So we want them to dig in, and that's what happens. So we only use group start, newly created start. Scale is 0.9 instead of 1. No idea why. Doesn't make sense in this case. And so, okay, now we have our roots, and let's merge them together with our jittery, literally, top part. So now we have our vines connected, and because we didn't allow our endpoints to be touched, moved at all, we have now them perfectly connected. You can see it right here. Like you can see the old one. You can see the connection. You can see that this is where they're meeting. We do fuse to merge them together. We do polypath to make each spline just like one spline instead of having 2 splines. So now we have each vine is just one spline. And we also reverse them because you can see that they begin from here. So we need to reverse them. Hold on. For some reason it doesn't work. It doesn't work with the point numbers, but it definitely works with vertex numbers. I'll show you later when we apply the chain SOP that it does matter even though it's not visible in this case. Okay, so now we have the mess and it's time to actually clean it. For this, we need another loop. So there is a wonderful node called Detangle. You can use it outside of the loop. Detangle. Just plug it in. It always requires, you can tell it here, that there is no previous position attribute specified. Usually it's like you need to apply specific rest position and stuff, but sometimes you can just use P for position, and that will be good enough. But in order to use this SOP the best way, you better put it into loop and do it several times. Just use it. Like you can see that even from here, it did detangle a little bit, but we just need more geometry and more iterations, and that's why we do for loop. But in this case, we do not do standard loop. We do feedback loop. Loop for a loop with feedback. That's what we need right now, because we don't need to go through each one of those splines separately. We want to go through all of them simultaneously, but many times. So that's what we do. And you can see that even here, the iteration method is different. So this is what we want. And now if you, like, if we do just this, if we do just this, and we do it, I don't know, 100 times, yes, it sort of will work, but the problem is that we don't have enough geometry over here. That's why you can see better results down below, where it definitely becomes smoother and definitely untangles, but it's not much changing here. I mean, they do get unstuck from each other, but still. That's why we do a little bit more tricks here. So let's look at the actual loop that I created. So let's say we have, let's do just one iteration. So the first, on 0 iteration, we have this. So we apply smooth, and smooth swap is wonderful. We apply it to everything except our endpoints. Pretty strong. After that, we apply detangle. You can see that they're moving. And in detangle here, yes, I used P as well. And I knew that I want my vines be around 3.5 centimeters thick. So I put it, I mean, not thick in radius. So the thickness would be 0.0. So the thickness of each vine would be about 7 centimeters. That's why I put the default thickness as this. And there is nothing else nothing else changed. So you can see already that it does work. And after that, we do resample to smooth it out again, and we use subdivision curves. And it helps to smooth this first crooked lines very, very much. So this was our iteration 0. After iteration 1, we have this. And each time, the more iterations we do, the better it's all smoothed, and the better it's the better the vines are getting away from each other. So in my experience in this project, 10 iterations were enough, but again, it all depends. It all depends on the project. And here, if you want more them to be more sophisticated, maybe just increase amount of length of the spirals. So will be more mass. As you can see, it did change, and now, well, then you'll have to clip them over here though, but, or you can do this, and now they're all only following up to their carve node that we were. Now, finally, with past deform, when you do fraction of curve lengths, that's when we actually only allowed spiral to go along whatever we have here, instead of just allowing it to follow its own geometry the way it wants. You can easily see it here. So we have pretty long spiral or super shorty. So let's get back to here. So depending on your taste and your need, you can have variations, or you can have even less loops, and then you have a bit more mass, bit less accuracy too, and more intersections probably, but it might be something that you would be willing to sacrifice. So let's go back to my normal spiral lengths. And also here you can add more copies, and for instance, you want 50 roots here, and you'll have again more geometry, more mass, or you can have 20 and it will be way less than that. So whatever suits you and your situation. Let's go back to my standard settings that I was using and it was shown as a result. So this is already looking good enough as to me, but I wanted to have some more. Later I added some more changes, because for instance, if we look into our tree here, you'll still see that there are some intersections here and there. You know what, let's no, actually I will show it. So it's the same loop as before, so only loop with feedback that takes all those geometries simultaneously. So what we do here, let's say we at loop 0. So we receive our geometry, we make a group node, and we use bounding region enable, and we use our tree as the object to check if something is inside of this object. Like in this case, you can see that actually our starting points, some of them are actually inside of our tree. So we select the points that are inside of the tree, and then we make the tree thicker with pole extrude with our usual thickness for the vines. And we use ray swap again, but this time we use minimal distance. So we select points, we use ray swap, and our selected points go into group intersect. And here we take our intersecting points and use method minimum distance, and we push them on the top of geometry. So you can see on this example, the points are inside of the tree, clearly inside of the tree. And after this, they're popping out. Okay, and then we do resample. And we do resample too with smoothing angles. And you can see, let's do this. And you can see how they change. So we had this, then we pushed it up, and then we smoothed it. And we do this several times again. And this, in many cases, it does help to push. In some cases, it pushes geometry, especially if you look at my tree here, you will see that it's kind of messy down here. So in some cases, it pushes actually roots underneath because it's minimal distance. If it's closer to here, then they do not get pushed up here. But if you're working with some, I don't know, hill, they would get pushed out. So again, very much depends on what you have for your mesh. So you can see that even if not much change, it pushes it up, and it mostly resolves clipping through the geometry. And so we're done with this. And again, you can do as many iterations as you can, and each iteration will make it smoother. After that, we go attribute delete, and we delete our normal attribute because we used to apply it to our points. And here, finally, it's time to actually turn our splines into actual roots. And we use standard for each loop. And we also do metadata here, each railing, I called it. And so we have 40 roots. And this time, while it's standard for each, now we have, in each iteration, we have just one separate vine. Okay, so let's see what we have. So we have our spline coming in. Then we do resample, and we do not change. We do not actually do resample. We only use this node to extract curve view attribute for each of the points. And you can see that again from the beginning to the end, we have our curve view from going from 0 to 1 through the whole length of the spline. And I think that's actually the case where I can show you that reverse here did makes no. Okay, hold on. I know that it worked. I checked. So we did our sample to get our curve view. Now I want to do a remap to, let's see, you know what? Let's do sweep to show the difference. Sweep. To show the difference, and we'll select a round tube, and let's do radius 0.0. Let's do 5. Let's do 35 as I wanted initially. So you can see that already we have our vine coming from the ground. Let's check this reverse. Still doesn't work. That's weird. Maybe it was working on the other side. That's baffling. Okay. Anyways, why I did remap. So the thickness of the vine is created by scale, and attribute scale is p scale. So here in this remap, we take our curve view, which goes from 0 to 1, and we turn it into p scale attribute. And we can, as you can see here, I made a curve. So not only, let's do this and compare. Okay, and you can see in the end of the curve, you can see actual change. So if we just do standard, if you can just do standard way, by the way, why it becomes, hold on, it becomes thinner. Why? It shouldn't. It doesn't have p-scale. Huh. I'm all lost. It should be just normal tube with the same thickness everywhere. I'm sorry for being puzzled like this. Oh, hold on. Is it the same or is it different? I think it's the same thickness. And if we want to, we can do actually apply scale and do something like this to make it go thinner by the end of the tube. Or we can do something like this here, and yeah, it's definitely thinner in the end. And do this, and then we don't need applying scale over here. So yeah, you can see that I can change this parameter, and I can choose how different it will be at the end of the spline. 3, 5. Okay, so we did this, and after that, I also want to show you how to make LODs for Unreal Engine, so it will be lighter for the scene. Let's jump there actually for the moment. So if we look into our mesh, you can see over here in the LOD screen that the high poly mesh that I have here is 900,000 polygons, which is crazy. So it's kind of nanite mesh. But if I zoom out, mesh LOD1 is 21,000, and it can be smaller too. And you can see that it looks actually pretty good from the distance to even being much smaller. Again, it's a question of taste. But what I did to achieve that is I actually, after this, I made a resample. So you can see made way less points to have smaller geometry. So I used standard sweep, and I used it just, even though it's round tubes, I use columns 4, could also do 3 for less polygons, or could do this polygons longer. And then I'll have way less geometry, even less geometry for LOD 1. So this was my LOD 1. Or I could do like a normal, just normal spline. I just wanted to do something different for high poly mesh. I actually wanted to use specific high poly. So I could do like way more, for LOD 0, I could use the same tube, the same spline, the sweep SOP, but without resampling and with like 8 sides. And then it will be like nice and smooth. And then for low poly, I could use something like this. So anyways, this is my low poly, and this will be my high poly. So what did I do here? I used chain SOP, and I repeated along this spline, I repeated the same mesh, and mesh is this. So this is a piece of geometry. Actually, it's made, I believe, from one of the trees from Megascans library. So I basically took the tree with more or less even thickness with details that I liked, and I just made it repeatable. So it's seamless. And also what I did the end piece. Basically just took the end points of it and scaled them down, and that's how I got my end piece. So I export these 2 pieces as a standard stem and end stem, and you can see them here. I import them as just file, then I do transformation, because As always, Houdini has everything in meters, so like 100 units, as this stem is precisely 1 meter, so it's 100 units, and so Houdini turns it into 100 meters. So we need to divide it, multiply it by 0.01. So this is our main piece, and this is our end piece, and they are black because of the probably because of material or something, and that's why we merge them together, and we do clean node to remove everything except UVs. So after we have our both pieces merged, the one thing we need to do to remember is that the first main stem has to go first into merge, and the second one has to go, the end piece has to go a second, because this one will be 0 and this one will be 1, and we need to know this difference for the chainsaw. So what I do here, I use my for my spline, I apply chainsaw, and I use all standard settings, except for ends and cap piece, I use piece number 1, which is this. And so you can see here, it actually does end with this little nice ending piece. And we can, in this case, we didn't even need to make the make the remap and scale, because we have nice ending piece. If you don't have one, you might just bring it to the 0 in the end if you don't have ending piece. Or you can just, you know, scale it down just for prettiness of it. Okay. And I remember that I needed this. I guess I didn't use it in the end, because I remember that I was planning to do different various thickness of each. That's why I used this in the beginning, but I just simplified it. I was using various thickness for each vine. So vines would be, you know, just one would be thicker, one would be thinner. You can also do approach where it will be thicker or thinner depending on its length. Something that I actually covered in my branches tutorial, trunk and branches tutorial for Sakura tree. So you can look at the approach there when we finding the longest spline and making it like base lengths, max lengths for all others, and then we can just scale, make others thicker, thinner if they are shorter. So yeah. So anyways, we repeat our high poly geometry along the spline. It's seamless, great. And now we just add in this geometry to HP group, just standard group primitives, all of them. That's why just put on enable, and that's it. And now we merge our high poly and our low poly together, and this will be the end of our loop. And now we have all of our vines on the left side almost ready to be exported. So let's get to it. So first we need to do is to split our high poly from low poly, and we split in this by group. And now we have high poly separately, and you still see that there are some intersections here and there, but they're not, as to me, they're not critical. And again, some more detangle nodes, or you can also, what you can also do is you can do in detangle, you can do it thicker. Let's say if we do one here, it will try to separate splines further away. So you'll see that, again, there will be still mistakes, also mistakes because of this. Because of this resampling that we do here. Yeah, so if I didn't need to push out my vines from the roots tangled here, I could have results which are much nicer results here. Also we could actually separate them. Instead of using them here, we could separate them and do all this smoothing only for the splines that are covering the roots, and leave these splines alone, splines from actual railing, leave them alone and only fuse them together afterwards. We could do that as well. So everything is just a question of what works in each particular case. In this case, I decided to, like, it's complicated enough, and I liked result enough to just ignore a couple of intersections. Okay, so now we split up our high poly and our low poly. And low poly still looks, of course, it's super low poly. I made this 4 sides, and I made it 0.2 here, so it wasn't that ugly. As you can see from distance, it kind of holds. Okay, so after we split, we do clean nodes for both of them to remove all the groups and attributes, whatever. So clean everything except UVs. And then we do need to create attribute of string attached to primitives. We give it its named attribute name, and this is the syntax for this attribute that it's supposed to be. So this is our geometry LOD 0. This is how it should work, how you should do it to make it work in Unreal. So for the high poly, we have LOD 0. For the second one, we have LOD 1, and you can have more LODs as well. You just need to put them into groups here, merge all of this together, then split them again, and just add attributes to it. Then I do triangulate, like standard procedure for Unreal's sake. Then I do apply normals to have smoothing groups, again for Unreal, so Unreal would not complain about lack of smoothing groups. And then I have, again, just for the beauty of it, I have my null to just give names, HP and LP. And after I'm done here, I merge them together. I apply material name to them, again for the sake of Unreal Engine. So if I would have several, if I would have this like vines connected to main mesh, I would be able to separate materials in Unreal Engine. And after that, I export them. And export is almost all standard. This usual export, uncheck export in this format that allows to edit the file itself. So we just need binary, convert units, compute smoothing groups from normals. Sorry. And file name. And what we absolutely need to do to have LODs is check build hierarchy from path attribute, and path attribute is name. So here under name, we created our path attribute for our LOD groups here and here. So this is crucial to have LODs, this and this checkbox. And after that, I export it. And while importing in Unreal, important things to do is importing, let's say I'm importing them anew. Railing left. Here, while importing, you need to check import mesh LODs. This is absolutely needed here, and then you'll be able to see LODs right away. Unreal does recognize it correctly. And that's it. And you can see that we have our high poly mesh and we have our low poly mesh. And in here, you can go and actually change the distance at which it switches from LOD from 0 to 1. And you can do this by auto compute LOD distances. You can uncheck this. And then it will allow you to select the screen size at which it becomes it switches. So you can see now it switches at 0.75. You can do something like 0.9, and it just switches faster. Okay, well, why is my apply changes not working? $99. Oh, come on. 0.99. Still definitely doesn't work, which is weird. 99. Okay, current screen size is 1.2. Okay, so this is 1. Yeah, it definitely switches. Okay, current screen size. I was just eyeballing screen size myself instead of looking how it does, what it does there. So yeah, but let's do 0.95 and 2 LODs, apply changes. Oh, yeah, and it does work. So and this is pretty much it. This absolutely the same process was done for the right side, except in the right side, I did less of the meshes. I just did 30 because it's shorter. Also, of course, I used with initial transform. I moved them to the right. So yes, less copies, and also yes, in here when we got our points, I transformed points totally different way and did totally different point jitter. So again, it only depends on the situation which you're at. And you can see everything is pretty much the same. Oh, reverse is unchecked here. Probably it worked here then. So weird. Oh yeah, it did. Yeah, so you see that it changed thickness, it changed the direction. So yeah, all these nodes are just, sometimes you need them, sometimes you don't. But anyways, I think that's pretty much it. If you have questions, ask in comments. I think it's a good way for lazy people like me to create some twisted vines instead of just sculpting them manually. So yeah, hope you like it. Have a great day and good luck.